Okay, so in this video, we're going to talk about how we can determine whether a function is even, odd, or neither. So we need to look at this in terms of even like an algebraic perspective, a graphical perspective, and even from a table. So let's look at the definition. It says a function is called an even function if for every input you have this notation here. So what this means is like you have your original function. If that original function is the same as when I replace x with negative x. If I get those two to be the same, then it's considered an even. So the graph of an even function is going to be symmetric with the y-axis. All right. Then we have an odd function, which says that you actually have, I'm going to rewrite this notation here, that it's basically saying it's the opposite x and the opposite y. So another way to write that is you have the original function f of x. If that actually becomes the opposite of your original function is equal to f of negative x, then it is considered odd. So this notation right here, opposite x's, opposite y's, is the same notation here. Okay. If it's odd, it's going to be symmetric about the origin. All right. So if I give you a graph, you can look at the symmetry, but right now I'm giving you an equation. So what we need to do is do this from an algebraic perspective. So we know that we need to compare f of x. So here's f of x. You just write that down, x cubed plus 2x. Then we need to, the easiest one to find is negative f of x, which just says to take the opposite. So we are taking the opposite of x cubed plus 2x. And what that's going to give us is negative x cubed minus 2x. So I'm going to write that notation down here. And then the next thing we need to do is replace x with negative x. So in the original function, and then we simplify that. Negative x to the third power is negative x cubed, and then 2 times negative x is negative 2x. So what we end up here is f of negative x is negative x cubed minus 2x. So now once we have this set of expressions over here, now we compare. All right, so we are supposed to, if it's even, we'd have the f of x is the same as f of negative x. Okay, so is f of x is f of x is x cubed plus 2x the same as this one right here, negative x cubed minus 2x. Well, we can say that it's no, so it's not even. Okay. So now let's check to see if it's odd. Odd says that your f of x, let's compare it. There's two ways to look at it. I like to go negative f of x and compare it to f of negative x. It's because most textbooks have it written this way. So negative f of x is going to be this notation. So negative x cubed minus 2x. Is that equal to f of negative x? Well, f of negative x is right here. Negative x cubed minus 2x. And you can see that they are equal. So this function is odd. Okay. Now let's try this for number 11. Notice that we have the letter S. So the idea behind those are not going to change. You want to be able to compare f of s and see if that is equal to f of negative s, in which case that's going to be even. And then you also want to compare the opposite of function s and see if that is also equivalent to f of negative s. And if so, it's odd. Okay, so let's try that. Oops. All right, so we've got s to the fourth. So what we're going to do is just over here, just keep track of all of our work. So we have f of s, which is the same. So it's just the same equation written down. And now let's do f of negative s. Okay, so f of negative s, everywhere where there's an s, you're replacing s with negative s. And that's going to be positive s to the fourth. Negative s squared is positive, so you're going to end up with positive 3s squared plus 7. So we're going to put that over here, s to the fourth plus 3s squared plus 7. So you actually see already that those are equal, but I'm just going to go ahead and finish this out. Negative f of s, which is the opposite of the original s function. And if I were to distribute, then I have this notation over here. And so now we compare. So let's compare. We're looking for which two of these are the same. So if we look at f of s and we compare it to f of negative s, right? So we have s to the fourth plus 3s squared plus 7. That is equal to s to the fourth plus 3s squared plus 7. All I'm doing is comparing those two down here. And then that means this is even. You can only be one or the other. You can't be both even and odd. So you're either even, you're odd, or you're neither.